Thank you so much for joining this lesson. We shall be discussing Mathematics Paper 1, Section 2, whereby a student is just required to select their best 5 questions out of a set of 8 questions. So this is the paper we are going to discuss. I hope you can see it clearly from that side. The Section 1 has already been discussed in this platform, Shifting Grades Online School. So please follow up with our programs, ensure that you're updated, ensure that you subscribe so that you may be receiving all the updates as we bring them to you. In the preparation for Kcse 2025, we shall be revising past Kcse papers and also mock exams like this one. So we're going to start right away. Thank you for joining. There are those who are already in the program and others will join us as we continue. So feel free to comment, to like, to share so that you may invite friends. Just share with a friend. Just to share. Yeah, I've also shared to some people. So we can now get started with the first question, which is a Form 2 question. 2 lines, L1, 2y minus 3x equals to 6, and L2, 3y plus x minus 20 equals to 0, intersect at point R. Find the coordinates of R. So R is the point of intersection of the 2 lines whose equations have been provided. With that, we're supposed to solve and get the coordinates. Knowing that, we have to solve the 2 equations simultaneously for us to get the coordinate of the point of intersection. Therefore, I'm going to solve the 2 lines now, the first line, the second line. So from the first line, which is 2y minus 3x equals to y, the second line, 3y plus x minus 20 equals to 0. So we can use one of the many methods of solving simultaneous equations. Remember, there is elimination method, substitution method, the matrix method, the graphical method. So allow me choose the substitution method, so that from equation 2, we say the value of x equals to positive 20 minus 3y. So for me to remain with x on the left-hand side for the second equation, then I have to take 20 to the right-hand side. It becomes positive, and 3y becomes negative that way. So in equation 1 now, I substitute x with 20 minus 3y. So this is 2y minus 3 instead of x. 20 minus 3y equals to 6. So 2y minus 60 plus 9y equals to 6. When I group terms together, I will be having 11y equals to 66. So when I divide through, for me to remain with y, I'm going to get the value of y as 6. 66 over 11 is 6 that way. Then the value of x, according to this equation here, shall be 20 minus 3, then the value of y, which is 6. So at this point now, I'll be having 20 minus 18, which is just 2. It means the coordinates of R, the point of intersection for the 2 lines, is now going to be 2, 6. Yeah, 2, 6. So that is the solution for the first part. Very simple. You're supposed to understand at the point of intersection, the equations are supposed to be solved simultaneously. Look at part B. Another line L3 is perpendicular to L1 at point R. The R that you've worked out here. That's why you're supposed to be very correct when working out the questions, because you find the values you are getting are required in the subsequent questions. Find the equation of L3 in the form y equals to mx plus c. Now that we have gotten the coordinate for r, now we go back to L1. 2y minus 3x equals to 6. We arrange it in the form y equals to mx plus c. We remain with 2y equals to, the part with x goes to the right hand side, so 3x plus 6. From this, we can say y equals to 3 out of 2x plus 3. This is now L1. From L1, we can say that gradient 1 equals to the coefficient of x when equation is already in this format, or rather the value of m according to this format here. The value of m is usually the gradient. If that is so, then it means the line 1 is having a gradient of 3 over 2. Then now here comes line 3 with a gradient 3. So the gradient 3 shall be, look at this. We are told that the two lines are perpendicular. For two lines that are perpendicular, the product of their gradients must give us -1. So we have to look for another gradient such that when multiplied by 3 over 2, we get -1. And this is going to be the reciprocal 2 over 3, but now with a negative 2/3, such that when multiplied by 3 over 2, we get a -1. Now that we have the gradient, we can express it using coordinate r, and another coordinate is let to be y. Then we say gradient, which is -2 over 3, is given by change in y. Change in y will be y minus 6, divided by change in x minus 2. Yeah, that's where we are. So we can now cross multiply and have 3 times y minus 6 equals to -2 multiplied by x minus 2. Then now we can open brackets. 3y minus 18 equals to -2x positive 4. To remain with 3y, we shall talk about -2x positive 22, right? Yeah, 4 plus 18, positive 22. So the value of y is going to be -2 over 3x plus 22 over 3. So that is now the equation in the format that the examiner wanted it to be. Look at part C now, the last part, so that we may get the first 10 marks. Another line, L4, is parallel to L2 and passes through -1, 3. Find the x and y intercepts of L4. So this L4 is parallel to L2. Let's get L2 first. L2 is here. 3y plus x minus 20. 3y plus x minus 20 equals to 0. We start by rearranging the first, this L2. We start by rearranging it. It shall be 3y equals to -x positive 20. So that will remain with y. We talk about -1 over 3x plus 20 over 3. With this, now we can say that the gradient for line 2 is -1/3. And now that it is parallel to line 4, then the gradient for line 4, let me call it M4, shall also be the same, simply because parallel lines have the same gradient. Parallel lines have the same gradient. Perpendicular lines have gradient whose product is -1. You should note that difference. Please note that difference. Parallel lines have equal gradients or the same gradient. So -1/3 now equals to change in y. We have to pick now x and y as a certain coordinate. So y minus 3 over change in x. x minus a negative 1. X minus negative 1. At this point now we can cross multiply, ladies and gentlemen. So this shall be 3 into y minus 3 equals to negative 1 into x plus 1. Remember, x minus negative 1 becomes x plus 1. So now this is 3y minus 9 equals to negative x, negative 1. 3y equals to negative x plus 8. Is that right? Negative 1 plus 9, we get a positive 8. So to remain with y in this equation, we talk about negative a third x plus 8 over 3. This is the equation for line 4. Now, with the equation for line 4, we can find both the x and the y intercepts. So the y-intercept can be extracted direct from what we're having here. So the y-intercept is 8 over 3, which is 2 and 2 thirds. Yeah, 8 over 3, which is 2 and 2 thirds. That is the y-intercept. Because when equations are in this format, y equals to mx plus c, we said this is the gradient, and this one is the y-intercept. So with this format, we extract the y-intercept that way. But the x-intercept, we have to say at the x-intercept, the value of y is usually 0. At the x-intercept, the value of y is usually 0. Therefore, we substitute y with 0 equals to negative a third x plus 8 over 3. So we remain with, this becomes a third x. We remain with 8 over 3 on this side. A third cancels, and the value of x becomes 8. So the x-intercept is 8. The y-intercept is 2 and 2 thirds. Yeah, 2 and 2 thirds. So that is it about number 1. We can check something in number 2, which is a question from transformations. As we get to number 2, let me bring to your attention our programs here, very enriching programs. We are having the best teachers around the country, whereby we are bringing them together so that they may offer chemistry, biology, physics, mathematics, and the languages, that is Kiswahili and English. So please enroll to our program. It shall be happening on what we call the Google Meet. So Google Meet classes are going to be very interactive. Unlike the YouTube, now we shall have a very interactive session here, whereby you can ask questions, you can answer questions from these particular teachers, and I'm sure by the end of the day, you shall get the best, and be sure that you're getting the best from the best. So kindly reach out to our programs. Our number is already attached, 0704 15 3366. Because of the much work involved, there will be some little amount for registration, very considerate amount. So please make sure you reach out to us through 0704 15 3366 for you to get something for yourself. Most of the candidates, kindly don't shy off. Come on board and interact with the best teachers. Interact also. You will also have an opportunity to interact with your fellow students from other schools. Don't just be used to the students of your own school alone. Please grab this opportunity and grow in your academics. All right. Number 18 now, the second question in this section. The diagrams in the grid below shows an object of a square ABCD and its image A prime, B prime, C prime, D prime, and a transformation T. So we have the image, we have the square, then its image. Part A of this, describe the transformation T fully. Which transformation is mapping the square onto the image, which is shown here? We're supposed to be very sharp, very categorical, very intentional for us to interpret this question well, because a student is supposed to know what they are doing first. So when you look at the two, you discover very well that they are of the same size. And if the size is the same, then, ladies and gentlemen, we are saying the two of them are congruent to one another. When they are congruent, then it means the transformation is involved is either it's not an enlargement first, it is not a shear, it is not a stretch. So what is it? It is either a translation, either a rotation, or a reflection. So for us to come up with the transformation, let's connect A to A prime. So we connect A to A prime that way. Then we bisect the line connecting A to A prime. You just bisect that line. And when you bisect, you realize that we shall pass through the x-axis. When you bisect the line connecting A to A prime, we shall pass through the x-axis. Let's do the same for B. We connect B to the image, B prime, already connected. Then when you bisect, you confirm the same, that we are passing through. After bisecting B prime, we are passing through the x-axis. Therefore, because after bisecting we are getting the same line, this is a conclusion that we are having a reflection. So this is a reflection. We first mention that it is a reflection. Then how do we describe a reflection? By mentioning that it is a reflection, then we quote the mirror line. Line y equals to 0, which is also called line x-axis. So the mirror line is the x-axis. It is a reflection along the x-axis. Yeah, that way. Because if we connect D to D prime and you bisect, you still confirm that you're passing through the x-axis. You connect C to C prime and you bisect, you conclude that the bisector for all the lines is just the same, and that is our mirror line. Then after that, ladies and gentlemen, we proceed to part B. We proceed to part B. We are told that another transformation U maps A prime, B prime, C prime, D prime onto A double prime, B double prime, C double prime, D double prime. Given that U represents a negative quarter turn, U represents a negative quarter turn. That means a negative 90 degrees. And that means negative 90 degrees means 90 degrees in the clockwise direction. 90 degrees in the clockwise direction. So that is the turn that you are going to experience. A negative quarter turn about the origin. So for us to describe a turn, which is also called a rotation, fully, we have to mention the center of the rotation, which in this case is the origin. In this case, the center of rotation is the origin. You can see people are joining. Remember to subscribe. Remember to share. Remember to invite a friend to this platform. I will be reading your comments. Please let me know where you are. Let me know where you are catching us from. Let me know your school. Let me just know your school, please. And thank you so much for joining. Color paper 2 is already uploaded, but we shall revisit. Thank you. Comment. Let's know where you are following us from. Let's know whether you're understanding something as we wind up with the transformation question. I'll be reading your comments later. Let's first do mathematics. Let's do mathematics first. All right. In the clockwise direction, it means now, let me change my color here so that my diagram is not that much congested. So I connect A to the center, like that. Then I measure 90 degrees in the clockwise direction. From the center, I measure 90 in the clockwise direction. So 90 measured in the clockwise direction shall pass there. Let me have it. -90 that way in the clockwise direction. Then after that, ladies and gentlemen, I'm now supposed to measure an equal distance. I'm supposed to measure an equal distance along the 90 degrees already measured. I measure an equal distance. I'm just confirming whether this is 90 degrees, and I've just realized I made a slight mistake. Yeah, 90 degrees. Then I measure 90 degrees that way. Then after measuring 90 degrees in the clockwise direction, I'm supposed to mark off a distance equal to from A to the center. Now I measure the same distance along here, which is going to be here. So this is our A double prime that way, A double prime. Then I do the same for B. So I connect B to the center. I connect B to the center. B to the center that way. Then I measure again 90 degrees in the clockwise direction. 90 degrees in the clockwise direction. 90 degrees in the clockwise direction. That way. Then now I also measure again and mark off an equal distance from B to the center. So I mark off an equal distance. And this is where it shall take me. This is going to be my B double prime that way. B double prime that way. I repeat the same for C and D. That means I'm supposed to connect. If it is D, I connect it to the center and I measure 90. So D, I connect it to the center of rotation, which is the origin. C to the origin that way. Then now I measure 90 degrees. I measure 90 degrees. Remember, I'm using the center of enlargement, the center of the rotation, sorry. So I measure 90 degrees that way. Let me measure the angle very keenly. I'm supposed to measure the angle very keenly. Sorry for the interruptions. Some people are making some calls here, but we are going to respond later. Okay, that way. So let me measure this distance now, and I mark it off. That way. Then an equal distance, as D is from the center, I mark off. So this is going to be D double prime. Then after that, now I finalize with point C. So I'm going to join C to the center. Yeah, C to the center. Let me do that. C to the center of the rotation. C to the center that way. Then now 90 degrees in the clockwise direction. -90 degrees in the clockwise direction. That way. Then I measure. I mark off an equal distance to C this way. So this is C double prime. Now I have all the coordinates already marked off. I'm supposed now to connect A to B, B to C, C to D, then back to A. Back to A that way. So now we have our rotated square. We have our rotated square that way. Confirm whether you are getting us very clear. Confirm whether we are clear from this side. And thank you so much for staying around. I can see people are really watching. Thank you, thank you, thank you. Thank you so much, STEM Smart Academy. Please make sure you follow up with his program. You can see he's on our program here, following up with us. So let's purpose to support his channel. Go there, subscribe and watch. He's a very great teacher. STEM Smart Academy. Please purpose to follow him. Let's continue now with concluding this. There are very great nuggets that I'm going to mention as we continue. A lot I'll be mentioning just as we continue about transformations. So make sure you remain connected to our program until the end. Remain connected until the end. Thank you, Collins. Use my WhatsApp number in the comments to share Sekanas 2025. I'm going to present it. So whatever is shared there is my WhatsApp number. You can save it and share Sekanas with me. I'm going to present. We continue. Part C of this question. A triple prime, B triple prime, C triple prime, D triple prime is the image of A double prime, B double prime, C double prime, D double prime, and an enlargement. Scale factor -1. Scale factor -2, sorry. Scale factor -2, center origin. You see, that's how an enlargement should be described. The center, the scale factor. Determine the coordinates of A triple prime, B triple prime, C triple prime, D triple prime, and so otherwise draw on the same grid. So let's enlarge this second image, center origin, scale factor -2. When the scale factor is -2, the image and the object are always on the opposite sides. Always on the opposite sides of the center. When the scale factor is negative, listen to what I'm saying. When the scale factor is negative, the image or the object and its image are usually on opposite sides of the center of the enlargement. This is what I mean. Let me do it practically. When we join A to the center, for us to get A prime, we are supposed to move to the opposite side. So we connect A to the center. Let me use the blue once again. A to the center. Then now we move to the opposite side. Something that we're supposed to know is the way we move to the opposite side should be, according to the scale factor, which is a -2, we move twice from the center. So the distance from origin to A, we mark it along this line 2 times. So 1, 2. So A triple prime now shall be there. We mark the distance 2 times from the center. Then we go to B. B is already connected to the center of enlargement. So we just need to prolong to the other side. And we also mark it off. We mark it off. Let me check whether we are very accurate. We mark it off. How many times once again? 2 times also. So B connected to the center, then we mark it off 2 times. So this distance should be marked from B to the center. We move an equal number of times. An equal number of times. I want to confirm what is happening with my accuracy, because I'm supposed to be very accurate in that thing. Very accurate. So let me continue enlarging these. That way. So when I move 2 times, for the first time I'm supposed to be here. Then for the second time I'm supposed to be here. So I don't know what is wrong with my... Okay, something that you're supposed to confirm is that the grid is not very perfect, but I'm going to try my best. So this is B triple prime. Let me now go for D and C. So I connect D to the center, D to the center, then I move D to the center, then I move to the opposite side. I'm supposed to move twice also. So from D to the center. So the first one should be here. Then the second one should be here. So this is where D triple prime is supposed to be. Yeah, D triple prime that way. I do the same for the last coordinate, which is C. I do the same for C. I do the same for C. So I connect C. Let me try to minimize for you to see. Yeah. From C, I connect to the center and I move to the opposite side 2 times. So from C to the center, then I'm marking 2 times. The first time I'll be here. The second time, this is where I'll be. So this is going to be my C triple prime. So with that now, we can draw ABC. ABCD. We are now having the enlarged square. The enlarged square is here. Yeah, that is the enlarged square. We have now enlarged. The square is enlarged. So we have performed all the transformations according to that question. When the scale factor is positive, the object and the image are usually on the same side of the center. They are usually on the same side of the center, but now they are supposed to be on opposite sides. That way. Look at the final answer, the final question. Name 2 pairs or name 2 pair of squares that are oppositely congruent. When you talk about opposite congruence, this is again very sensitive. We mean that if we move one of the squares into the other, they cannot fit into one another unless you tilt. Unless you tilt, they cannot fit into one another. We have to tilt, and even after tilting, they don't fit. That is opposite congruence. Direct congruence is whereby when you shift one of the squares or one of the images into the other, they fit into one another without tilting, or after tilting they can fit. So when you talk about direct congruence, this is where we have rotation and what we call translation. And for rotation, we can also have enlargement, scale factor -1. Yeah, it behaves like a rotation. It usually behaves like a rotation. So those ones give us direct congruence. When we talk about indirect congruence or simply opposite congruence, this is where reflection has been involved. So don't be struggling to know the pair which is oppositely congruent. Just discover where reflection has been involved. And there was, in this case, where was reflection involved? In the first case, even before we started, the first square and the first image. So we will talk about A, B, C, D, and A prime, B prime, C prime, D prime. That is the only pair which is oppositely congruent because it is a reflection involved. You cannot lift one of the squares and fit directly into the other one. But where rotation is involved, there is direct congruence. Where rotation is involved, there is direct congruence. Let that one be mastered very well. So that's all about the question on enlargements. We are now in number 19. A very interesting question. Number 19. We are told that a triangle PQR is inscribed in the circle, full stop. There should be a full stop there. Then we are told that PQ equals to 7.8 centimeters, PR 6.6 centimeters, and QR equals to 5.9 centimeters. Just as you can see, find part A, the size of the angle QPR. QPR is the angle at P. That way, QPR, that's what you are finding first. This is a trigonometry 2, whereby we call it a solution of triangles. Solution of triangles. So in solution of triangles, ladies and gentlemen, we have a sine rule and cosine rule. In this case, we are going to apply cosine rule. We know very well, if the angle is P, the opposite length is called small letter P. If the angle here is Q, the opposite length, small letter Q. If this is R, small letter R on the opposite side. Then this is how we relate them using the cosine rule. I hope you guys are following. Remember to subscribe, please. Remember to share. Remember to invite somebody to our broadcast. Kindly remember to invite people to this particular broadcast so that we may grow together. So we usually say this. When we take the length P squared, this one is usually the same as R squared plus the other length, which is Q squared, then minus 2 multiplied by R and Q, the cosine of the angle at P, which is capital P now. I've used the diagram which we can familiarize with, the diagram we are already having on the board. diagram that you can see. So the length, okay, it depends now on the angle that you need to find. That is the angle at P. So we say the length P, which is 5.9 squared, equals to R squared 7.8 squared plus 6.6 squared minus 2 multiplied by 7.8 multiplied by 6.6 cosine of P. Yeah, times cosine of P. So that's a product times cosine of P. So now we can work out 5.9 squared, which is 34.81 equals to 7.8 squared plus 6.6 squared. This gives us 104.4 minus 2 multiplied by 7.8 multiplied by 6.6. So minus 102.96 cosine of P. That way. Let's now subtract 34.81 minus 104.4. This gives us negative 69.59 equals to negative 102.96, the cosine of P. To remain with the cosine of P, we are supposed to divide through by negative. We divide through by negative 102.96. This gives us 0.6759 equals to the cosine of P. So how do we get the angle P now? By finding the cos inverse. If the cosine of P equals to 0.6759, then P equals to the cos inverse of 0.6759. So the value of P shall be shift cosine, and I'm getting 47.78. 47.48, sorry. 0.48 degrees. So that is the angle according to the cosine rule. So you are supposed to be in a position to remember the cosine rule. And if we cannot remember it, remember that it is in the mathematical tables. You can always refer there. You can always refer. Once you refer, please, okay, you should know that that's why in most of the cases in math, we don't allocate the marks for the formula, simply because some of the formula are already provided in the math table. So we award marks for proper interpretation. We allocate marks for proper interpretation of the formula. So apart from memorizing the formula, understand how you are supposed to apply it. Understand how you're supposed to apply it. Part 2 of this question, part B. Part B. This is a very wonderful question, ladies and gentlemen. Very wonderful. The radius of the circle. We are supposed to know that when a circle has been, when a triangle has been inscribed, in a circle, the radius of the circle is usually equal to the sine rule. So we say that the sine rule, which says in case we have P out of the sine of P, this is the same as R over the sine of the angle at R equal to Q over the sine of the angle at Q. This is usually equal to 2 multiplied by twice the radius of such a circle. Twice the radius of such a circle. So we can use P, whereby we know both the side and the angle. The side is a 5.9 P out of the sine of 47.48. This is equal to 2 multiplied by their known radius, 2r. 2r. So how shall we get the value of r? So let me have 5.9 divided by the sine of this angle. I'm getting a 8.005 equals to 2r. So how do we get r? We divide it through by 2. So this is going to be 4.00, actually to 2 decimal places. So this is just okay, 00 centimeters. That is the radius now. Yeah, 4.00 centimeters. 4.00 centimeters. And finally, find the area of the shaded region. 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 Okay, the shaded region is outside the triangle but inside the circle. So we take area of the whole circle minus area of the triangle. Look at that. Area of the whole circle minus area of the triangle, we get the shaded part. So let's get area of the circle. We're saying the shaded part equals to circle minus triangle. So for the circle, we need pi r squared minus triangle half AB sine theta. Half AB means 2 of the sides, 7.8 and 6.6. 7.8, 6.6. Sine, the angle between them. The angle between them is 47.48. So 22 over 7 multiplied by 4 multiplied by 4. This is 50.29 minus half multiplied by 7.8 times 6.6, the sine of 47.48, giving us 18.97. 18.97. So when we subtract all this, 50.29 minus 18.97, I'm getting 31.32. This is a square centimeters. Yeah, square centimeters. So that is the area of the shaded part. Outside the triangle, inside the circle. So triangle we subtracted from the circle. Circle minus triangle, get the shaded part. As we continue learning, we are now adjusting to number 20, still in section 2. Remember to purchase airtime of any amount for any network by simply going to your M-Pesa, Lipa na M-Pesa option, then the pay bill number is already attached, 737356. 737356. Then now the account number is the phone number that you're purchasing the airtime for. Yeah, the account number that you're purchasing the airtime for. Then you proceed to enter the amount, you complete the transaction, and you shall receive your airtime instantly. Trying to look at your comments, and you guys are really doing well. So please continue following. Thank you so much for tuning in. Invite a friend. Remember our program here for August holiday. Enroll by getting in touch through our number 0704 15 3366. Let us grow together in our academics. Let us grow together. Okay. Number 20. The figure below represents a model of a solid structure in the shape of a frustum of a cone with a hemispherical top. The diameter of the hemispherical part of the top and the top of the frustum is 70 centimeters. The frustum has a base diameter of 28 centimeters and slant height of 60 centimeters. Part A, calculate the area of the hemisphere or the hemispherical surface. We know that area of a sphere is usually given by 4 pi r squared. So an hemisphere should be 4 divided by 2, which is 2 pi r. So we say that area or surface area equals to 2 pi r squared. 2 pi r, the radius. Remember the diameter is 70. So the radius shall be 35 squared times 35 once again. So what are we getting here? 2 by 22 over 7 multiplied by 35 times 35, giving us 7,700 square centimeters. 7,700 square centimeters. Hope we are together in that. Just application of a formula, correct substitution, you find your answer. Remember, just as I said, just as I quoted, in measurement, we need to remember the formula very much. Once you remember the formula, then you stand a good chance of scoring all the marks, because it's about substituting well, using your calculator and getting everything. Calculate the slant height of the cone, from which the frustum was cut. Slant height of the original cone, in other words. So we're going to assume an original cone where this frustum was obtained. An original cone is going to be assumed that way. This original cone is having a certain slant height. So there is a small slant height, small letter L, which was cut off for us to obtain this frustum. So we are supposed to say this, that according to similarities and enlargements, the smaller cone which was cut off is similar to the larger one, or to the original. So when we take the diameter of the original out of diameter of the smaller, the ratio should be the same as that of the slanting height of original. Slant height of original should be 60 plus unknown L out of slant height of the smaller, which is now small letter L, that way. So 70 times L equals to 28 by 60. This gives us exactly 1680. Yeah, 1680 plus 28L. We can group terms and take 70 minus 28. This gives us 42L equals to 1680. So the value of small letter L is going to be 1680 out of 42. I'm getting exactly 40. So the smaller cone, which was cut off, is having a slanting edge 40. What did you want? Slant height of the original. So for the original, capital L equals to 40 plus the 60 that remained there, which is 100. Yeah. So for the original cone, we shall have the 40 and the 60 giving us 100 centimeters. 100 centimeters. Part C, the curved surface area of the frustum. Now for the frustum, the curved surface shall be, we take original cone pi RL minus smaller cone pi RL. Remember, curved surface of a conical part is usually given by pi RL, whereby R is the radius and L is the slanting length. Therefore, being a frustum, we need original cone pi RL capitals minus the smaller cone that was cut off pi RL. So this now shall be 22/7 multiplied by radius of 35 times a slanting edge of 100, then minus 22/7 multiplied by a radius of 14 multiplied by a slanting edge of 40 for the smaller cone that was cut. It is having a radius of 14. Because the diameter is 28, then the radius shall be 14. And for the bigger one, the diameter is 70, the radius shall be 35. That way. So we can now compute this. 22/7 multiplied by 35 multiplied by 100. This gives us 11,000 minus 22/7 multiplied by 14 multiplied by 40, 1760. Then now we are supposed to subtract 11,000 minus 1460, giving us exactly 9240. Square centimeters. 9240 square centimeters. 9,240. What are we finding next? The area of the base. The base for this particular solid, the base is circular. So pi r squared. Pi r squared. Pi r squared. 22/7. 14 times 14, giving us 616. Then total surface area. The total surface area shall be the bottom plus the curved surface, which is 9240, plus the top hemisphere, which is having a surface area of 7700. I hope everything has been computed well. So let me now carry out the addition. Plus 9240 plus 7700. This is equal to 17,556 square centimeters. Square centimeters. So that is the total surface area. Yeah, the total surface area. It's my hope that you've followed very keenly. You need to master the formula. You need to master the formula because we are dealing with measurement. Measurement has quantities like volume, surface areas, densities, we are supposed to understand all of them. Please make sure you are conversant with all of them. Look at this now. The data below are marks scored by 45 students in a mathematics test. 45 students in a math test. Using the data below, or the data above, complete the frequency distribution table below. Frequency distribution table below for two marks, 30 to 39, 40 to 44, 45 to 54, 55 to 69, 70 to 79, 80 to 84. All right. I want to introduce something here, and that is going to be the tallying column. The tally column. So that for every class, because the examiner has already given us the classes, it is only the frequencies that we don't know. It's only the frequencies that we don't know. Only the frequencies that we don't know. So with that, we should be able now to know the frequencies on our own, whereby this is what we are supposed to do. We mark each of the values and we use a stick to represent according to the classes. So we are going to place each mark to the class where we're going to place each mark to the class it belongs. Yeah, I'm using a different color. Thank you for that suggestion. Look at this. If it's 32, for example, we mark 32 like that. We place a stick to the class where 32 is. 81, a stick to where 81 is. 38, a stick. 84, a stick. 35, a stick. 82, a stick. 74, a stick to the class. 80, a stick again. 39, a stick here. 83, they are already 4, so we bind them using the 50 one that way. 79, a stick. 83, once again. 81, once again. This is a very good class. 42, 42 should be placed here. 41, the same class. 52 in this class. 65 in this class. 43, we get to here. 80, 84, 41, 41 should be here. 53, this class. 76, this one. 46, this one. 70, this one. 40, 40 they are already 4, so we bind that way. 43, we continue. 45, this class. 71, we bind like that. 50, this particular class, whereby we have to bind that way. 46, this class. 50, same class. 70, this class. 54, here. 78, here. 80, we bind. 42, here. 51, this class. 72, here. 53, we bind like that. 60, here. 31, we bind. 54, here. 45, same class. And 55, finally, here. So now we can tally. We can now tally. Thank you so much for being around. I hope you have followed keenly on how I have developed the tallying column. Now with that, we can write the frequencies now. From the first class, we are having 5. The second one, we are having 7. In the third one, we are having 10 plus 2, which is 12. Here we are having only 3. Then in this class, we have 8. And here we have 10. That way. So the tallying column is not compulsory, but it is usually good. It helps you improve your accuracy. It helps you improve your accuracy. Remember to subscribe. Remember to share so that you may invite a friend. If you have a revision paper somewhere that you'd like us to go through, kindly forward it to us through 0704 1533 66. On the comments, you can check my number. On the comments, please check my number there. Also on the screen, the number has been attached. So please reach out. You can also reach out for our programs. You cannot enroll to our programs and remain the same. We are getting the best tutors across the country to help you benefit so much as you revise for your Kcse. So kindly reach out so that you may enroll for the 3 sciences: physics, chemistry, biology, for mathematics, and for the 2 languages, Kiswahili and English. Please work with us and watch yourself improve. Look at part B, a very interesting question. Draw a histogram to represent the data above. Draw a histogram to represent the data above. Something that you should be able to notice is that the classes are not equal in length. 30 to 39, 40 to 44, 45 to 56. They are different in lengths. And now that they are different, we have to come up with what we call FD, the frequency density. So when classes are not the same, we don't plot frequency. We plot frequency density against what we call the class limits. So from the first class, frequency density, ladies and gentlemen, is usually given by the frequency out of the class length. Frequency out of class length. So the first frequency of 5 and a class length of 10, we are going to get 0.5. The next one is frequency of 7 divided by 5. Class length is 5, so I'm getting 1.4. Remember, class length is usually given by upper class boundary minus lower class boundary. Please notice that. Class length is given by upper class boundary minus lower class boundary. Let's get to that once again. For that to 39, the first class, the upper limit, or the upper boundary, the upper boundary is 39.5 and the lower 29.5. That is why the class interval is 10, 5 over 10, 0.5. Now, 40 to 44, we have 44.5 and 39.5, giving us an interval of 5. So 7 divided by 5 is 1.4. The next class is 54.5 from 44.5, a class interval of 10. So 12 divided by 10 is 1.2. 12 divided by 10, 1.2. We are now going to take 69.5 minus 54.5. This is giving us a class interval of 15. So 3 over 15 is 0.2. 3 out of 15, 0.2. Frequency divided by class length. Frequency divided by class length. Let us master this. Frequency divided by class length. 79.5 is the upper boundary minus 69.5. We are getting 10. So 8 over 10 is 0.8. 0.8. And finally, we have a class frequency of 10, but the interval is 5. So 10 over 5 is 2. 10 over 5 is 2. That way, 10 divided by 5 gives us 2. The axis has already been plotted. So we are supposed now to plot frequency density for this type of data against the class boundaries. Against the class boundaries. So for the class frequency densities, we can use intervals of 0.2. Yeah, 0.2. So that from 0, we go to 0.2, 0.4, 0.5, 0.6, 0.7. Sorry. The interval should be smooth. We are supposed to use uniform scale. Sorry for that. 0.6, 0.8, 1.0, 1.2, 1.4, 1.6. We even have values of 2. We can also talk about 1.8, then 2.0. Yeah, 2.0 that way. But you can also use a smaller scale, which will accommodate everything without using up to the last, without using up to the last square. So let me still work on this. Please allow me change the scale so that we can comfortably have all the values represented. So what we shall have here is on this axis. Sorry for that interruption. Let me just change the scale kindly. Let me just change the scale, and I hope you are watching. Have you subscribed to this platform? Have you invited at least a friend? At least. Even if you're not inviting everybody, just invite one friend, please. Just one friend. Let's use 0.4, please. 0.8, 1.2, 1.6, 2.0, 2.4. Yeah, that way. This is now better. This is better for the frequency densities. This is better. Okay. Now with that, we can have another scale for the horizontal axis, whereby we can break the axis and we start with the least class. Actually, we can use intervals of 5 from 30 to 80. There is 50. You need 10 squares, and we don't have 10 squares, or we have them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we have them. They're enough. So we assume a class just before this one, whereby this particular class should start from 29, or we assume 25 to 29. So that will start with 24.5, 24.5, 24.5, 29.5, 34.5, 39.5, 44.5, 49.5, 54.5, 59.5, 64.5, 69.5, 74.5, 79.5, 84.5. Again, we have used all the squares. I didn't want that, but let's just proceed. We have used all the squares. So no problem. Let's now plot. Let's plot. The first class is running from 29.5. We are using the boundaries 29.5 to 39.5 with 0.5 as the height. With 0.5 as the height. So we start from this way. So that is the first bar. It's going up to 39.5, up to 39.5, up to 39.5, that way. Then the other one starts from 39.5, from 39.5 all the way to 44.5, and the height is 1.4. 1.4 is exactly between these two. Between 1.2 and 1.6, we have 1.4 there. So exactly at the mid there, we have the height. Then we talk about 44.5 to 54 to 54.5, and the height is 1.2. The height is 1.2. So a height of 1.2, a height is 1.2. That way. That way. Again, from a 54.5, that is the lower boundary, to 69.5, all the way to 69.5, and the height is 0.2. The height is 0.2. So 0.2 is exactly between 0 and 0.4. Exactly between 0 and 0.4, that way. So that is the class. And finally, or not finally, from 69.5 to 79.5, height 0.8. Height 0.8. So 0.8 is here. That way. So this is the class. Then we have the final class with a height of 2. The last one with a height of 2. Yeah. A height of 2. With the height of 2. That way. The height of 2. So this is now what we are calling the histogram. This is the histogram now. Very well represented. Are you guys following? Thank you. Thank you for being around. I can see you're following. And this is quite encouraging. So now we proceed to the next part. After that, look at what the examiner needs now. Using the histogram in part B above, determine the median mark. We determine the median. The first thing that we're going to establish is the median class. The median class. These are 45 students. So 45 over 2 will give us what? Or 45 plus 1 over 2. Yeah, because they are even, because it's an odd number, we talk of 45 plus 1 over 2. We get 23. So the mark scored by the 23rd student, the mark scored by the 23rd student is our median mark. The mark scored by the 23rd student is our median mark. So we go to this particular histogram now. From the first class, or from the first bar, how many students are there? There are 5. Then in the second, how many students are there? We have 7 of them. How to get the number of students is that we are supposed to multiply to get just the area. In other words, area of the bar represents the number of students. Remember, the number of students is the frequency, and frequency density is calculated by F over W. So when we find area, we will be multiplying frequency density times width, which is equal to frequency, the number of students. So the area in the first is 5. In the second, it is 7. When you add up, we are getting 12. In the third, we are going to get 12 once again. There is 12 there. So when you add up everything, you discover that we are having 5 plus 7 plus 12, which is now 24. And 24 is beyond the middle student, who is 23rd. So we will say this, that in the third class, we don't need all of them. We are having 12. So from 23 is it 9, 11? Yeah, 23 minus 11, 23 minus 12, which is 11. So we have 11 students now, which must be added to the first 5 and 7. So these 11 students, we need area to represent 11 students from this second class. Therefore, the second class is having a fixed height of 1.2. We should multiply it by a known width to give us 11. So how do we remain with the width? The width that we need is going to be 11 over 1.2, which is 9.1667. That is the width we need to use for the area to be 11. So from 44.5, look at this. From 44.5, we are adding 9.1667. So that when that width is multiplied by the fixed height of 1.2, we get the remaining number of 11 students. So the mark that we will get after adding 44.5 to this, I'm getting 53.67. 53.67. Now that will be our height. 53.67, and we draw that height. So we are taking 44.5 plus the height that we need. This is going to be 53.67 to 4 significant figures. 53.67. This is the median to 4 significant figures. We just work out the height, which is going to be we work out the mark scored by the middle student. The mark scored by the middle student. The number of students that failed if the pass mark was 49.5. So we go to 49.5. The number of students who failed. So we go to 49.5. So 49.5 is here. Remember, number of students is represented by area. So 49.5 backwards now. The number of students there. The area below that. So we are already having 5, 7, and 5, 7, and a fixed height of 1.2 multiplied by the width. We want the area at this point, so that we add all of it. So this is a 5. That is 5. So 12 plus 1.2 by 5, 6. This is 18 students. 18 students. 18 students. 18 students failed. 18 students failed from this histogram. 18 students failed. So that's how you're supposed to work out such a question. 18 students failed. Please ensure to review this working. Remember, after the presentation, this question or this paper is still going to be available. The presentation is still going to be here. Even after this presentation, you'll be able to find what we are discussing still in the same channel. So make sure you get back and get the best. Get back and get the best. Part 22 now. Number 22. Again, a very good question, which I hope you guys shall understand. A very simple question. We can work it out. We can work it out. The shaded region in the figure below is bounded by the curve y equals to x squared and the lines y equals to 4 and also line y equals to 16, just as you can see. Y equals to 4, y equals to 16, the curve is here, the shaded area is here. As you can see, very clear. Find the coordinates of P and Q. Now, these are the points of intersection of a line and a curve. For example, the curve y equals to x squared meets the line y equals to 16 at point Q. So for Q, we can solve simultaneously because they are intersecting. Then we can equate the two. X squared equals to 16. So that the value of x becomes the square root of 16, which is plus or minus 4. Now that according to this graph, we can see that we are having the positive part of the x-axis alone. Then the coordinates of Q shall be the x is 4 and not negative 4. Then the y is 16. Now for coordinate P, the intersection point of x squared and 4. So that x becomes plus or minus 2. So that because P is also on the positive side of the x-axis, the coordinate of P shall be 2, 4, that way. So we have the coordinates of P and Q. The coordinates of P and Q are already established. The next question. What are we told to do? Estimate the area of the shaded region using trapezium rule and a height of 1 unit. Trapezium rule and a height of 1 unit. So trapezium rule means we are not going to use integration this time around. We are finding the trapezium rule. Trapezium rule. So something that you're supposed to know is that, let me just draw this that way. This is point x equals to 4. And when I draw another line here, this is at x equals to 2. This is at 0. Yeah, those are things that I want you to understand first. That is what I want you to understand first. With that understanding now, ladies and gentlemen, we'll be able to get the area first, area of the whole shape. Assuming this is O, X, Q, Y, that way. O, X, Q, Y, the whole shape, which is rectangular. Then we need 16 units on the Y. Remember, the scale on the Y is different. That's why we are having 16 units being shorter than 4 units. So the scale is different. 4 units here. So the whole shape is going to be 16 times 4, which is 64 square units. 64 square units. Then now to apply what we are calling the trapezium rule, then we are supposed to get the area below the curve. The area below the curve, which is going to be, we can have those units now at 1 and at 2, so that we get the heights now. So we have the y values, x, y. When x is start from 0, 1, 2, 3, 4. This is 0. X equals to y squared. So this is 1, 2 squared, 4, squared 9, squared 16. So we're having the coordinates because we said y equals to x squared. So if y equals to x squared, then we are already having the coordinates. We have the coordinates there. So that's what I want you to know, that for the trapezium rule, we need to get those values. I'm checking your working, guys. Thank you so much for following. Thank you for being around. You can comment, please. Let's know where you are watching us from. Let us know where you are catching us from. It's good for you to communicate. It's good for you to show us that you're learning with us. So now we are on the trapezium rule, whereby we are saying that according to the trapezium rule, we usually say that area is given by half the uniform height, then the first height plus the last one, then 2 multiplied by the other heights in between. 2 multiplied by the other heights in between, that way. So this is the general formula for trapezium rule. So we need to say half multiplies 1. Then we are having the first height is 0, the last one is 16, plus 2 multiplied by the heights in between now. The heights in between. So this is 0.5. This is 16. This is 2 multiplied by 14. Yeah, 2 multiplied by 14. So 28 and 16, 44 times half. This is going to be 22 square units. 22 square units. So 22 square units is all the area from 0 to 4 below the curve. All that unshaded part, all this unshaded part is going to be 22 square units. So there still remains some area here. There still remains some area there, which has to be subtracted. So the area from 0 to 2, but above the curve. From 0 to 2, but above the curve. We are going to get it. This is how we shall get it. I'm going to take first from 0 to 2. These are 2 units, and upwards 4 units. So I'm going to take 4 by 2 first. So 4 times 2 to give us 8 square units. Then after this, I will use integration now. I integrate from 0. I integrate the curve from 0 to 2 so that I may subtract. I integrate x squared from 0 to 2. So this shall be x power 3 over 3 from 0 to 2. So this shall be 2 power 3 over 3, 8 over 3. So this is 2 and 2 thirds. 2 and 2 thirds. So 2 and 2 thirds is the area here. 2 and 2 thirds is the area at this point. If that is the area at that point, then it means we need to get this shape, the unshaded, between y equals to 4 and the curve. Y equals to 4 and the curve, whereby we take the whole area of 8 minus what we've just gotten. 8 minus 2 and 2 thirds. 8 minus 2, 2 and 2 thirds. So I'm getting 5 and a third. 5 and a third square units. 5 and a third square units. So with 5 and a third square units now, it means we have 5 and a third at that point, and we're also having the whole of this area below the curve as 22. So we add 22 now. So unshaded, the whole unshaded now is going to be 22 and 5 and a third. This is 27 and a third square units. 27 and a third square units. If the unshaded is 27 and a third, and the whole of the shape, the whole of that shape, we got what? The whole of that shape, we got 64. We just need to subtract now. 64 minus 27 and a third. 64 minus 27 and a third. This is 36 and 2 thirds square units. Yeah, 26 or 36 and a third square units. And that is according to the trapezium rule. According to the trapezium rule. Let me apply very quickly the mid-ordinate rule. So for the mid-ordinate rule, we are going to approximate using the middle parts, the middle values of x, whereby from 0 to 1, we shall pick 0.5. We pick 0.5. Then from 1 to 2, we pick 1.5. Then from 2 to 3, we pick 2.5, and 3 to 4, 3.5. That way. Then we get the respective values of y, 0.5 squared, because the function says y equals to x squared. So 0.25, then 1.5 squared, 2.25, then 2.5 squared, 6.25, 3.5 squared, 12.25. That way. So now we say that area equals to the height multiplied by all the values of the heights added up to the last one. So we need the height, which is the difference between the heights, just one. The first one, the first mid-ordinate, the second mid-ordinate, the third mid-ordinate, and the last mid-ordinate. That way. So this is a 0.25 plus 2.25 plus 6.25 plus 12.25. This is exactly 21. So I'm getting 21 square units. 21 square units. So with 21 square units, I want you to know this. You know, this thing is this way. Let me resketch. We are finding this area. So 21 is the whole of this. The black area is the one we are getting 21 using mid-ordinate tool. The black one is 21 square units. The black area, 21 square units. Then the area at this point, which I'm going to paint green, the green area, or let me use blue for this case. The blue one has already been calculated. The blue one has already been calculated as 5 1/3. 5 1/3 square units. 5 1/3 square units. So now we are going to say the area which is below the red shade is going to be unshaded. 21 plus 5 1/3, which is 26 1/3 square units. So now we pick the whole area, 0 through this part, through this one, and this one. 64 minus 26 1/3. 64 minus 26 1/3, which is 37 2/3. 37 2/3. 37 2/3. So using the mid-ordinate, we are having 37 2/3. Using the trapezium, 36 2/3. So those are the two areas which are slightly differing. So that's what you add to understand. You must know the formulas. Once again, you have to be knowing the formula for you to navigate through such a question. Wow, thank you for following. Remember to subscribe to our platform. Remember to share with your friends so that you may invite them to our broadcast. Just remember to share. We are now in number 23. Number 23, whereby this is a word problem from quadratic equations and expressions. A carpenter, or a carpet, measuring x plus 4 meters by x minus 1 meters, laid down in a rectangular room measuring 2x by x meters, leaving out uncovered floor near the walls round the room. If the carpet is 36 square meters, calculate the area of the uncarpeted floor. Area of the uncarpeted floor. So this is how the thing is. We are supposed to interpret very well that there is a room here, rectangular, of course. A rectangular room is here. Now, this room is having some dimension. Then there is a carpet which is going to lie. There is a carpet here which is going to leave some uniform path uncovered. This is the carpet. Now the carpet is measuring x plus 4 by x minus 1. Then the room itself is measuring 2x by x. Further instructions are telling us that the carpet is 36 square centimeters. So the area of the carpet itself now, when we take x plus 4 and we multiply by x minus 1, we should get 36. That is the equation that we should be able to form. Calculate the area of the uncarpeted floor. Let's get the value of x first. X times x minus 1, then positive 4 by x minus 1 equals to 36. This is x squared minus x plus 4x minus 4 equals to 36. X squared positive 3x minus 40 equals to 0. Yeah, minus 40, because minus 4 minus 36 becomes minus 40. Minus 40 that way. With this now we can proceed to solve. We need a product of a times c, negative 40, and a sum of the value at b, which is just 3. So the two factors multiplied negative 40, they have to be 8 and negative 5. When added, positive 3. So x squared, we replace now positive 3 with 8x minus 5x minus 40 equals to 0. From the first two, we factor out x to remain with x plus 8. Then we factor out negative 5 to remain with x, again plus 8, equals to 0. So x minus 8, x plus 8, x minus 5 equals to 0. From the brackets, x plus 8, outside the brackets, x minus 5 equals to 0. From the first, we can say x equals to 5 or x equals to negative 8. But now that we are dealing with length, we cannot have a negative value of x. So we choose the first value of x. So x equals to 5. If x equals to 5, it means the room measures 5 by 10. And the inner carpet, the carpet measures x is 5 plus 4, 9 by 3. That's why we are getting 9 by 4. X minus 1 is 4. 9 by 4. That's why we have 36. So uncarpeted area, the uncarpeted area shall be 5 by 10, the room itself, minus 36. So 50 minus 36, ladies and gentlemen, this gives us 14 square meters. These are meters. Square meters are uncarpeted. 14 meters squared are uncarpeted because the room is 50 square and the carpet is 36 square meters. That is what we're supposed to understand. A very interesting question. Very, very interesting. We are winding up with the paper, and thank you for staying around. We are concluding very soon. Thank you for the follow-up. Thank you. We are winding up. Yeah. Yeah. At part B of the same question now. Part B of the same question. Actually, I didn't know that our video is this clear. Wow, this is great. This one is very great. The video is very clear. My handwriting very good. So you have all the reasons to pass. You have all the reason to have your grades shifted. Please subscribe, share to invite a friend. Yeah, share to invite a friend. Let's check the part B of this. What is the examiner telling us? That 20 square centimeter tiles were to be used to carpet the uncarpeted section. To carpet the uncarpeted. In other words, to carpet the 14 meters squared. Calculate the cost of carpeting the whole floor if the carpet costs 300. And each tile costs 100. Let's get the tiles needed here. So 1400 square meters should be multiplied by 100,000. This is 140,000 square centimeters divided by 20, the area of one tile. The area of one tile, which is 20. So we are getting 7,000 of them. 7,000 tiles are needed. The area is 140,000 square centimeters, and one tile is having an area of 20 square centimeters. So 7,000 tiles were needed. Now 7,000 tiles being needed, each tile is costing 100. So this is going to be 700,000 Kenya shillings plus the carpet, which costed 300 per square meter. So the carpet is covering 36 square centimeters and it's 300 per square meter. 300 per square meter. So 700,000 plus. I think there is something which we are not doing right here. There is something we are not doing right. Let me just read something in a clear manner. Let me interpret something well here. Sorry for that. Sorry for that. Let me also fix my pen for some charging. But as you can see, we are told that 300 per square meter. 300 per square meter. Then one tile costs 100. So the tiles are 7,000, each 100. Then on the other side, we are told that the carpet costs 300 per square meter. Square meter, how many square meters have been carpeted? 36. 36 square meters were carpeted. Then 7,000 tiles, each costing 100, were also needed. This will be now the cost. This will be the total cost. So 36 times 300, giving us 10,800 plus 700,000 that way. So this will give us 710,800 Kenya shillings. This is now the cost of tiling. This is the cost of carpeting the whole floor. This is now the cost of carpeting the whole floor. You are supposed to understand the question accordingly. So that is it. And it's my hope that now you've gotten it. Makunga Kitale, thank you so much. Remember to enroll to our programs kindly. Remember to enroll to our program. We are winding up with all these by going to number 24 finally. Remember, our consultation line is still attached to the wall, still attached. The displacement S of a particle after t seconds is given by displacement S equals to 40 t power 3 minus t squared minus 3t plus 3. Find part A, velocity of the particle when t equals to 2 seconds. So for us to get velocity, we need to differentiate displacement with respect to time. When we differentiate this, we're going to get the power of 3 goes down here to multiply 4. So it becomes 120t. The power now decreases to power 2 minus the power is 2 in the second term. So 2 multiplies t and the power becomes 1. Then the power is 1 here. So we get a negative 3 and t becomes now power 0, whereby the power disappears. In the last term, which is a constant, there is a t power 0. So when we drop the power 0 to this part, the constant completely disappears. So the velocity function is 120 t squared minus 2t minus 3. What are we finding? Velocity when t equals to 2 seconds. 120 2 squared minus 2 into 2 minus 3. Let me find this now. 120 into 2 squared minus 2 into 2 minus 3. I'm getting 473 meters per second now that it is velocity. Yeah, meters per second. Actually, physics together with the Kcse mathematics are coming next week. Thank you for the reminder, but that is in our planning. We are bringing physics to you. We are also told to find the time when the particle is momentarily at rest. Momentarily at rest means velocity becomes 0. That is the meaning of momentarily at rest. So according to the velocity function, when shall velocity become 0? 120 t squared minus 2t minus 3 equals to 0. That is it. So we solve this one now quadratically so that we may know the values of t when the particle is momentarily at rest. Momentarily at rest. So let me find the value of t. We can use several formula like the quadratic formula. T shall be negative value of b plus or minus the square root of b squared minus 4ac. Then we divide everything by 2 times the value of a. Negative b means negative 2 plus or minus the square root of negative 2 squared minus 4. A is 120, C is negative 3. Then we divide everything by 2 by 120. We can use our calculator well, 2 plus or minus. So I'm having a negative 2 squared is a 4. Then I have to add, definitely, 4 multiplied by 120 and 3. So I'm getting 1444. So I take the square root of 1444, which is 38. Then everything divided by 240. So I'll be having 2 plus 38 out of 240, or t equals to 2 minus 38 out of 240. So the first value of t means 40 out of 240, which is 1/6 seconds, or t equals to negative 36 over 240, whereby we cannot entertain negative time. So the answer remains that t equals to 1/6 seconds. Yeah, 1 out of 6 seconds now should be concluded to be the final answer. 1 out of 6. 1 out of 6. So you should be able to apply the quadratic formula. Look at part C. The maximum displacement of the particle. Maximum displacement. So at maximum displacement, maximum, velocity is usually 0. When the particle has covered the maximum distance possible, the velocity is usually 0. So maximum displacement is when velocity is 0. And that is when t equals to 1 over 6. Therefore, we say that this maximum displacement will be given by, we get back to 40 t power 3. So 40 t power 3, a sixth power 3. Is it plus or minus? Minus t squared. So minus 1 over 6 squared, minus again 3, 1 over 6. Then finally, plus 3. So what you're supposed to know, the reason why we are using 1 over 6 is at maximum displacement, velocity is usually 0. And when velocity equals to 0, we have calculated the corresponding time. When velocity is 0, time is usually 1 over 6. So now we can find this. 40, I open brackets 1 over 6. Then I raise to power 3 minus 1 over 6, I square. Then I subtract 3 into 1 over 6. Then I add 3. So this is going to be 2 and 71 over 108. 2 and 71 out of 108 meters. How about this is displacement? Wow. A very good question. A very good question. Then finally, ladies and gentlemen, we have a part D, which says we find acceleration of the particle when t equals to 3 seconds. So acceleration equals to, we differentiate velocity with respect to time. We are having the velocity function here. So when we differentiate this, 2 multiplies 120 to get 240 t minus the next term, which is t is to power 1 in the next function. This one, t is to power 1. So 1 multiplies negative 2, it remains negative 2, and the constant disappears. The constant 3 just disappears. So now acceleration shall be 240 into 3 minus 2. So 240 into 3 minus 2. This is going to be 718 meters per second squared. Now that it is acceleration. Yeah, meters per second squared. So that is the paper, the section 2. Remember to visit again the channel. If there is something you want to clarify on your own, please get back and have it clarified for you. You can also reach out through our number as attached on the wall. Remember to reach out for our powerful program here. See you online. Thank you so much for following. Have a good night.